All right, welcome back to Mr. P Helps with Precal. This is Unit 4, topic number 3, lesson number 2. So we're going to be changing polar to rectangular form. Okay, so polar equations, as you saw in the last video, polar equations are basically represented by r and theta. So r happens to be the radius of the circle, and theta happens to be the direction that it's going. So examples of equations. Now we're talking about equations, not just points now. These would be polar points. If we're talking about equations, we're talking about ones that happen to be something like r equals 2 times sine of theta. So they're represented by r equals. So anything that's r equals, and it's going to be represented by sine or cosine of some sort of angle theta. Typically, most likely it'll be written like this. So r equals like 5 times cosine of theta. Something similar to these examples. All right, so given the point P with the polar coordinates r and theta, all right, so x is always, as you learn back in like basic trigonometry, is that x is equal to r times cosine of theta. Because of the whole right triangle things, you know, in a unit circle. So if you have a right triangle that's right here, then you know the radius, which is the hypotenuse, being multiplied by cosine of this angle is always going to be equal to the x. All right, so y is always going to be the radius times sine of theta. So remember, y is always the height. Sine, that's why sine is always the height of the triangle, and cosine is always the x of the triangle, which is the left and right. All right, so using that information, we can convert each one of these these are polar points. We're going to change these each pair into rectangular coordinates. All right, so basically I'm going to use these two equations. I'm just going to plug this into both of these, and that's going to give me my point. All right, so where is this point? So that's going to be x is equal to the radius of 2. 2 is the distance, being multiplied by cosine of 5 pi over 3, which is the angle. And then y is going to be equal to 2 times sine of 5 pi over 3. Now, once again, you have to be pretty good at your unit circle. You have to remember that 5 pi over 3, anything over 3 is a multiple of 60 degrees. 60 times 5 is 300. This is basically the same thing as 300 degrees, which is a 60-degree reference angle in the fourth quadrant. Now, cosine of 60 degrees happens to be 1/2. All right, and since it's in the fourth quadrant and cosine is positive in the fourth quadrant, I know I just said a whole lot of things, but hopefully that's stuff that you all remember from the last unit. So that's going to be positive 1/2. So the x equals 2 times positive 1/2. And then obviously 2 times 1/2 is 1, so x equals 1. Over here, sine of 60 degrees is square root of 3 over 2. So y equals 2 times square root of 3 over 2. 5 pi over 3 members in the fourth quadrant, and sine is going to be negative in the fourth quadrant. Yeah, sine's only positive in the first and the second quadrants. All right, so now this is over 1, and then basically these two's cancel, so you get y equals negative square root of 3. So there's your coordinates. So you have 1 comma negative square root of 3 in rectangular form. All right, so I'm going to do the same thing over here and do x equals negative 6 times cosine of 3 pi over 4. And y is going to be negative 6 times sine of 3 pi over 4. Okay, so now 3 pi over 4, remember, is going to be in the second quadrant. It's a 45-degree reference angle. So it's going to be square root of 2 over 2. But it's cosine, and cosine in the second quadrant is going to be negative. So x equals negative 6 times negative square root of 2 over 2. These can both cancel out. Divide by 2 turns this into a 3. And then you've got x equals a negative times a negative is a positive. 3 times the square root of 2. All right, I'm going to leave it like that. I know it does say round to the nearest hundredth, but I'm actually just going to leave it the way it is and be precise. All right, so this one over here, y equals negative 6 times. Now, sine of 45-degree reference angle is also square root of 2 over 2, but it's in the second quadrant, which makes it positive because sine is positive in the second quadrant. I can once again cancel these out. This is 3, this is 1, and then I'm left with negative 3 square root of 2. All right, so there's my coordinates, which happens to be 3 times the square root of 2, comma, negative 3 times the square root of 2. And once again, you could simplify this by using a calculator, and it's going to give you an exact, not an exact, sorry, it's going to give you a rough estimate of about where that's at. All right, so now we're going to apply that to converting these equations to rectangular form. So now we're going from, we're doing polar coordinates to rectangular points. I'm sorry, we were doing polar points or coordinates to rectangular points, and now we're going to talk about equations. So changing these equations into standard rectangular form. So remember, rectangular form is a form that represents x and y, whereas polar is representing r and theta. So remember these things right here. This we just talked about. R times cosine of theta is equal to x, and y is r times sine of theta. I know it flipped it around, but just think of this as x equals r times cosine of theta. Same thing. And then also know that Pythagorean Theorem states that anytime you have a right triangle, x squared plus y squared is equal to the radius squared, because the radius really is the hypotenuse of the right triangle whenever you're making your triangle in a circle. So if it's like this, then the radius literally is the hypotenuse, and x squared plus y squared equals r squared always works whenever it's a right triangle. And then also remember the tangent of theta is always equal to y over x. Okay, so we're going to use these to our advantage in order to convert polar into rectangular form. Well, the first one's actually going to be the easiest. If we know r is 7, then I can literally just put that right in here and put 7 in for r, and there you have it. X squared plus y squared equals the radius squared. Well, I know the radius is 7, so then x squared plus y squared equals 49. And you can just leave it like that. Remember, this is back in geometry. This is a circle. I'm going to take this extra step. You remember how to graph these circles back in geometry? This would have a 0, 0 as the origin is basically the center of the circle, and the radius is 7. And then 7 that way, 7 this way. And then there you go. Then you've got your circle. All right, so number 2. So this time we're just given theta. This is a little bit trickier, so I'm going to use this right here. And what I'm going to do is I'm going to do tangent of both sides. So that's going to give me tangent of theta equals tangent of 2 pi over 3. Now, tangent of theta is y over x. So that's an easy transformation, turning tangent of x, which is y over x, and from this into this. Now, tangent of 2 pi over 3, remember back to your unit circle, 2 pi over 3, once again, is a 60-degree reference angle in the second quadrant. And tangent of 60-degree angle is square root of 3, and that's it. Now, tangent in the second quadrant is going to be negative. So it's going to be negative square root of 3. All right, so the last thing I would do is, since I want to relate this to x to y, is I would just simply multiply both sides by x. And I got y equals negative square root of 3 times x. There's your equation, which you can now put that into your calculator and see what that would look like. So you couldn't necessarily put this polar into the calculator, but you can put this into the calculator. All right, so for the next question, this one's going to be probably the trickiest of these 6 questions. I noticed that secant is the inverse of cosine. So the first thing I'm going to do is I'm going to change this. I'm going to change secant to 1 over cosine. So basically that keeps the 3 on top over cosine of theta. Or you could say 3 times 1 over cosine of theta, but what I did is I just multiplied the 3 times the 1 on top and the 1 times cosine of theta. I basically just skipped steps right to here. Now, the next thing I'm going to do is I'm going to multiply both sides by cosine of theta in order to get rid of this. So now I have r times cosine of theta equals 3. Well, r times cosine of theta is the same thing as x. So this all gets replaced with x, and x equals 3 is the equation. So basically, this is a linear line that's just going straight up and down. Sorry, straight up and down. So if you're looking at a Cartesian graph, you're looking at an equation that looks like this. So that's changing this to x and y. Remember, x and y is something you can usually put into your graphic calculator, unless it's not a function like this. All right, number 4. This is very similar to question number 2. So I'm going to take tangent of both sides. So that's going to give me tangent of theta is equal to tangent of 5 pi over 6. And then tangent of theta is the same thing as you see right here as y over x. And tangent of 5 pi over 6. Now, 5 pi over 6 isn't quite pi. It's a little bit less than pi, so it's in the second quadrant. It's actually it's a 30-degree reference angle in the second quadrant, and tangent of 30 degrees is square root of 3 over 3. All right, now just multiply both sides by x, and you've got your equations. Square root of 3 over 3 times x. There's the equation you can put in your calculator. All right, number 5. These two questions are going to be done pretty much the same way. And this can be a little bit trickier. When you'll notice the trick here is when you have r equals and you have these normal sort of polar equations. The trick is to multiply both sides by r. So now you have r squared equals negative 2. I'm going to put the r right here. It really doesn't matter. Commutative property of multiplication. Negative 2r cosine of theta. Doesn't really matter which order you multiply them in. Now, r squared is the same thing as x squared plus y squared. So I can change this into this. And now this, r times cosine of theta, is the same thing as x. So this is really negative 2x. Now, next thing I would do is I would set this equal to 0. So x squared minus 2x. I'm going to leave a little bit of room here, plus y squared equals 0. Now, normally this is where you would stop, but I'm going to take that extra step to kind of relate this to what you did back in geometry. I'm going to complete the square. So I'm going to complete this square over here by doing b divided by 2 squared. b divided by 2 is negative 1, so half of this x term is 1, negative 1, and squaring that is positive 1. So I'm going to add 1 to both sides. So this is now a perfect square of x minus 1. If you use FOIL on this, you get this. So yeah, we're using some math that you used a long time ago. Plus y squared equals 1. Okay, so now we've got our standard rectangular form. We now know that the center of the circle is right 1 up 0, right 1 up 0, and we know the radius is 1. So we know it's going to be there, 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 and there, and voila. That's what you did back in geometry. That's how you would graph it. Because you can't put that in a graphic calculator because it's not necessarily a function. All right, number 6 is going to be done just the same. I'm going to multiply both sides by r. R squared equals 8 times r cosine of theta. Then I'm going to replace r squared with x squared plus y squared. And I'm going to change this to 8 times r cosine of theta, remember, is x. So now I've got x squared minus 8x, leave some space, y squared equals 0. Half of this is negative 4. Negative 4 squared is 16. I'm going to add 16 to both sides to complete this square. That means this is a perfect square of x minus 4 plus y squared equals 16. Okay, so there we go. So now I know if I was graphing this, this is right 4 up 0 and a radius of 4. It's going to look very similar to this, only it's going to be a much bigger circle. All right, I think I'm going to have to stop right there because I'm already at 13 minutes. Thanks again for watching. Please give it a like if it helped you learn something about changing polar form to rectangular form for both coordinates and equations. Have a great day.